That's good. That's good. I'll redo the start, shall we? So that's what we're in there. So we've got some studios in there, and again, there's lots of opportunity there. Again, we've got some really great community investments that we're in. We're very proud to have a Queen's Award for sustainability. It's a big part of who we are. Ultimately, being industry leaders and innovating on top of that means that we're able to do that. Again, another reason why we're here. And ultimately, platinum investors in people. So we've got some awards that we're proud of. People, Planet, and Profit, they are the three mantras that we work by. And again, it's all around innovation there, and AI is a huge part of that, and definitely something that is a value to our clients and a value to us. Fundamentally, everything that we do is around innovation. So it doesn't matter what we touch or what we're working on, we're always pushing the boundaries, and we spend a huge amount of time on pointless tasks that might seem pointless at the time. And it takes a real investment to actually see through that, and it's built into our culture of lots and lots of time innovating, of which 50% of it will go nowhere and 50% of it in 5 years' time will be somewhere. That's just the way it works, and we understand that. Really, really quickly, how we work there. So we are a creative agency, so we have creative consultancy. So it's all about communication. So it's about talking to people and helping people talk to each other. We're big in corporate. We have creative. So I don't get angry, but I'm a creative director. So you don't want me anywhere near. I'm literally going to glaze over in a minute with you if you go too far. And we've got a production house in there as well. And these are all the things that we do here. So that's the breadth of what we're talking about in the 450, all of which different types of AI kind of touch us. But ultimately, it's been absolutely brilliant to see the passion that goes into running this event, which is incredible, and also the passion that goes into the work, which is absolutely world-class leading as well. And we're very proud and happy to support that, and we'll probably keep doing it, I think. Thank you.
Cool. Nice one. Thank you very much. Yeah. And come on in if you've just joining us. Do find a seat. Okay, cool. So tonight is about finals, and this wouldn't be possible without the RPG and without Aston Uni. So to welcome us in Aston Uni, we have Dr. Ulysses Bernadette from the Computer Science Department, who also chaired the finals tonight. Ulysses, over to you. Thank you for having us.
Well, welcome everyone to Aston University. It's really great to see so many people at this event, and I think community building is very important. That's how we can be creative and let the ideas flow. And of course, Aston University, the strength to industry is one of the things that we are very proud of. So this is, let's say, one version in which we engage with people in the wider community, not just industry, anyone who's also interested in these topics. I think it's important that we, also communicate, generally speaking, about AI, and not just AI, computer science, and then university education, maybe as a in a wider context. So my name is Ulysses. I am standing here as the substitute for Aniko. Aniko, unfortunately, couldn't make it today. I hope she's online. So Aniko is the one who really, from our side, has invested a lot in making this happening, and is the sort of our liaison really to BrumAI. Aniko also happens to be the director of the new Aston Center for AI Research and Application, and I happen to be the deputy. So another reason that I am substituting her here. And so this is something fairly new, that we created this center. The Aston University wants to have several centers, and we thought AI really needs to be on the map, and we need to do this. And in the end, it all goes back to community building as well. So having a research center helps us within the university to find synergies, to find ways in which we can collaborate, but also to the outside world. And so this competition that we have tonight, this is graduates or students from our AI program, so master students from our AI programs that have submitted to this competition. And so we will have 4 presentations. Unfortunately, the first speaker couldn't make it tonight. And so the way this will work, so we'll have, everyone has 5 minutes and 1 slide. I'll try to be quite strict. So the idea is to get your idea across quickly, elevator pitch kind of Wow, that's a long elevator. So maybe that's not the right analogy. It's more like waiting at the traffic light in Birmingham speech. And there will be 3 categories. We will have most innovative awards, most impactful award, and a community choice award. Now, there will be 3 panels. The panel members are over here. So we have Anandi, you're representing BrumAI, and you're going for the most impactful. Is that right? Is that you? Is there a community? Okay. Then Joe, you're here from Aston University. You're the one with the innovation. That's correct, right? Okay. And oh yeah. And then we have. Let me see, who is that? Gemma. You're the one with the innovative award. Okay, now I got it right. Good, excellent. And so the panel will listen to the talks, will disappear, and sort of come to a conclusion. And we also do a community award. That's where all of you can vote. And so how we're going to do this is going to be an online, a QR code that you can scan with your phone. We'll only show it at the end of the presentation, so you're not getting too distracted, filling in forms while someone's still speaking. In case someone is not equipped with a phone, we also have a paper version here. Just some forms here. Does anyone need a paper form to do the voting? There you go. There's a couple, if you want to hand them out. And good. I think that is everything that needed to be said about the competition. So then, in that case, I would call Abdulhamid. You're the first one.
Let's do setup. Hi, welcome. Final. So excited you're here. So let's try this, and then I've got the slide over here. You tell me if everything is okay with it.
Yeah. Hello, my name is Hamid. I'm here to give a presentation on epitope prediction, catching the optimal train. So take a moment to envision a world altered by an epidemic of catastrophic proportions. Schools closed, businesses shut down, hospitals operating well beyond capacity, and life as we knew it suspended. A dreadful scenario, isn't it? But we lived this through COVID-19. An antidote to this grim reality came in the form of vaccines. And do you know what played a critical role in accelerating vaccine development? In silico methods. In other words, computer-based simulations that mimic biological processes. Before the advent of in silico methods, we had traditional techniques like X-ray crystallography. This is a technique that literally involves shooting X-rays at crystallized proteins. It is as laborious, time-consuming, and expensive as it sounds. On the other hand, in silico methods have revolutionized our world. They have revolutionized our world. We can now preview how vaccines behave at the molecular level without even stepping a foot in the lab. So let's delve into the crux of these computer-based models, the training set. Think of it as the teacher for the predictive tools we build. The quality of the training set often determines the accuracy of the prediction. Research has indicated that training sets specific to an organism, let's say a virus, tends to perform higher when targeting that specific virus. On the flip side, when we aim for a broad spectrum of pathogens, a heterogeneous training set performs better in terms of generalizability. So here's the dilemma. There's often a trade-off between specificity and generalizability. So here's the million-dollar question. What if you could optimize this training set to offer both specificity and breadth? What if you could fine-tune this teacher to be effective in every kind of condition? My research aims to pinpoint this optimal balance. Taking a closer look at the slide, we see on the left strands of protein that represent organisms. Notice those that are highlighted. They represent those selected for our optimized training set, which we use to predict epitopes. Epitopes are specific parts of the antigen which an antibody latches onto. Think of epitopes as locks and the vaccines which we develop as the key. The better we can predict these locks, the better keys we can create, which translates into more effective vaccines. For my research, I'm focusing on lentiviruses, a family that includes HIV. We're talking about a viral family that is affecting nearly 38 million people globally. But why this work is crucial is not just because of it's focused on lentiviruses, it's its potential to be adapted to other viruses, say hepatitis or influenza. So how do we intend to find this optimized training set? Enter genetic algorithms, nature-inspired algorithms that mimic the process of, that mimic natural selection. Imagine a scenario of survival of the fittest, but for data sets. We begin with a diverse training set mix, and then we run it through multiple computational iterations. With each pass, less effective sets are discarded. And as the algorithm evolves, it begins to zero in into the most suitable candidates. For a clear perspective, let's delve into some numbers. The MCC value, a holistic measurement that takes into consideration lots of metrics like the false negative, the false positive, the true positive. And we see for the optimized training set, it lies at minus 0.295. And for the Prepared 2.0 model, it lies at minus 0.068. Interestingly, our model performs marginally less effectively than the Prepared 2.0 model. This result is particularly striking, especially when we consider that our model is just a basic random forest with no hyperparameter tuning and trained on a limited data set of about 10 organism IDs, about 10 organisms after the final iteration, after being exposed to only about 30 organisms initially. So on contrast, the Prepared 2.0 model leverages a far richer data set and a far more complex model. So as a proof of concept, it's our results show considerable promise. We can see that I believe that the model can always improve if we broaden the data set. By also fine-tuning the genetic algorithm, we can the genetic algorithm can improve and gradually create what we might call a perfect training set. In conclusion, the future of vaccine development is not just about creating new vaccines. It's about fine-tuning our methodologies for quicker, more effective ways of discovery and deployment. This research isn't just focused on current problems, it is preparing us for future challenges as well. The world is moving towards a universal strategy for rapid, effective vaccine development, and not just a specific solution for a specific problem. We are not just talking science, we are discussing the blueprints for a more resilient future. Thank you all for listening to my talk.
Thank you very much. Absolute perfect timing on the second. So while the next speaker, Izegbua, is getting ready, we come up here. We have time for one question. If the panel has one question they would like to ask.
Well, I got a question for you. This is a really meaningful work, and potentially can benefit a lot of people. But could you tell us what you have done in order to make the data set become more easy to select, or the more accurate data that could be set? Yeah.
If I understand your question, for it to be easily selected, the point is for the model to be generalizable. We are not looking at any particular data set. So basically just randomizing the selection. Yeah. Because we feel if you use any data set, for instance, let's say the old out data set contains lentiviruses. We want to create a model that does not depend on lentiviruses, a model that depends on every other thing other than lentiviruses. So it could capture patterns that would also allow it to be effective in predicting something like lentivirus that will make it very generalizable, irrespective of the virus.
Yeah, to follow up, actually, you try to select a subset of the data set such that your prediction could be more easily done.
Yes.
Then that means you select something, at the same time you deselect something. So yes. How can you make sure that the thing you deselect is not the one with potentially answer over there?
That's why I said like the next steps for this project would be to expand the project, to use probably a machine learning server and get as much organisms as we can. Obviously, that is why it might not capture a lot of things, because 10 organisms is a very limited data set. So, but even with that limited data set, we can see that there is a likelihood for it to do what we expect it to do. So if we do catch as many data sets, as many organisms as what we can load in there, because just that 10 organisms could run for about, on a basic system, could run about like 7 hours to get results. So obviously we need as much data sets as we can on a bigger computer.
All right, I think we should move on. But Thank you for that. And
do you have a pointer? Do you have a pointer? All right. Hello, everyone. Good evening. I hope you're all feeling good tonight. Izegbua Ihongbe, and I've just completed my master's dissertation in user studies in evaluating explainable artificial intelligence in medical radiology imaging. So we've got respiratory diseases, which are one of the largest killers in our world, especially in the past couple of years. All of us have all been affected by COVID, either directly or indirectly, in the past couple of years. So we can see the effect that these diseases have on ourselves. Now imagine the strain that you have on healthcare organizations worldwide or hospitals. This strain has caused an evolution in automatic or intelligent systems which help us to diagnose these diseases even faster, so we can provide healthcare faster to those affected. So enter deep learning models, convolutional neural network. These have gotten great results in trying to diagnose these illnesses, trying to give us faster results, trying to do it faster than humans can do it themselves. But one problem is they haven't been fully adopted by hospitals, by healthcare services worldwide. Why? We don't understand how they work. They are black box models, and it happens not just in medical areas, but in every sector, in every field. People want to understand how these intelligence systems work before they are able to adopt it, use it, and provide the results to their patients or services to their customers. So here we have explainable artificial intelligence. These are methods. This is a rapidly or recently growing field of AI, which helps us to explain these deep learning models that we do not understand, right? And what we're going to focus on today is the visual explainability. We have some X-rays here. If you take a look on the left side, we have X-rays and CT scans here, which I have used a deep learning model to diagnose whether you're positive or negative for pneumonia or positive or negative for COVID. This is an example of what our deep learning diagnostic models do for us today. But I have applied explainability methods on them to show us why a deep learning model will say this has pneumonia or this has COVID-19. So if you take a look at the red part, just a brief overview of how it works, it shows you a heat map of what area of the chest it categorizes as the problem area. So that is why the deep learning model has categorized this as pneumonia, because that red area of the chest is inflamed. It shows symptoms. Same thing as the COVID-19 part as well. So we have two methods here, GradCam and Lime. Lime is the black and white one, which is graying out areas which it feels is not important, but it's showing the areas that it feels are important. Great. So this is wonderful, right? It's explained the problem, it's explained the diagnosis, but still there is a low adoption because the doctors or the clinicians or the medical professionals have not accepted this yet. They've not said this works, so we can't accept it. They haven't said that yet. And that's the gap that this research is trying to bridge. It's trying to give these results to the medical professionals and say, evaluate this. Tell me, does this work for you? Is this useful for you? And these are the metrics that we're using. We're using clinical relevance. Like, is this a useful explanation to the diagnosis? Can you use this to make a decision in the hospital? Do you understand the formatting which is presented? Is it clear? And do you trust it? Which is super important, especially in a sensitive field like medicine. So quite a number of these images were given to 26 medical professionals from 1 to 10 years of medical experience, right? They have a broad range, but they've all worked with radiology images. And they looked at this and said, just as a summary, on average, yes, this looks like it looks good, but it's not there yet. But I need more to be able to adopt this. And these are what they've recommended. These are the recommendations, the major recommendations they've made. Textual diagnostic reports. Medicine is not a field where you give one answer and expect to swallow it or use that as a diagnosis for your patient. They will want to see reasons. They want to see holistic information. Show me a report as to why you feel this is pneumonia or this is COVID. What are the other issues that this person could have in their chest, which is not pneumonia or which is not COVID. Give me other information. Give me a good view, a holistic view of what could be wrong, and don't just give me one answer. We have improved AI knowledge. A lot of medical professionals are not tech savvy, as most of us are here, right? So they depend on an easy mode of information, easy format of information, but they still want to understand better to be able to know, okay, this is how much trust I should put in these results. The third recommendation is their involvement in AI development. Yes, engineers and technicians, we're good at developing, we're good at measuring accuracy, 100% is great. But do we really encompass the requirements of clinical professionals when we are developing these systems? We need to include them in the development process. And this is what future work is going to be based on. It's going to be based on having diagnostic reports to give the clinicians a holistic view. It's going to be based on helping the clinicians understand the problem better, and also including them in the development process. And once this is done, we see that the impact we're trying to make here is to help doctors, help clinicians save lives. Now imagine in the midst of COVID, when you walk into the hospital and after a couple of minutes, you have a diagnosis and you're able to know what is wrong with you and why you're coughing or what the issue is. That's what we're trying to impact by having this research done. Thank you very much.
Thank you.
Yeah. So that was really good. Thank you.
Thank you.
One of the questions I have is like you presented all the feedback you received from the doctors.
Yeah.
Was it 20 in your sample?
Sorry?
You said 20 clinicians or
26.
26, okay. So did anybody say like, I don't want to use AI or something like that?
Of course, I did have that feedback. So what I did at the beginning of the research was to get a baseline sentiment analysis of how medical professionals feel about AI tools in their vocation, right? And we see most of the sentiment was from neutral to positive, but then again there was also a few people who would have the feedback of they don't think it's going to work. They've spent their whole lives learning this, right? So they don't think it's going to work, because how could a machine come and do this in a few seconds, in a few minutes, right? So after looking at these results, after evaluating it, you see the sentiment kind of change from I don't know if I trust it, to it looks like it works, but I want it to be more accurate. I want to understand it better. I want to know what the decisions are better. And it looks like I feel I could then trust it to make good decisions. But then again, there's still some people who, after seeing the explainability results, this would not work, right? The accuracy is horrible. It's not going to provide enough information for me. I know it better. So yes, I did have.
So what
feedback.
recommendations have you got for to address those group?
So out of these three major recommendations, the one that was most prominent in accepting these solutions was the improved AI knowledge. They really want to understand how it works, because then it helps them to know what amount of trust to put in this system. There's also recommendations in having the system give its own confidence level of a diagnosis, right? So a diagnosis could be, this is, I'm sure, like the deep learning model could say, I'm 75% sure this is pneumonia, but then again, I'm 20% sure that it could be, let me say, for example, lung cancer, right? So they want to see that holistic view. They want to understand it better. They want to have a well-rounded knowledge of everything that's going on, so that it can aid them in how much to trust decision, or how much to also verify their own suspicions when they're looking at a patient. Thank you.
Right. Give you that.
You tell me if these slides look okay to you. And well done, welcome to the final. Well done for making that far. This is super exciting.
So, good evening, everybody. I'm Nissy, and the topic of my presentation is iterative refinement of two-fingered robotic grasps. This project is basically a synergy between robotics and AI. So, before I jump into the project, I just want to welcome everybody and thank everybody for joining us today. And getting back to my project, so this project is a synergy between AI and robotics. So, in robotics, robots do lack human level dexterity even now. So this project is dedicated to improve the grasp quality of robots so that they could manipulate the object in their environment successfully. So my project, the name of my project is Iterative Refinement of Two-Fingered Robotic Grasps. So we have three important features in our project. Grasp quality metric, a baseline model, and a neural network model. So imagine if you're trying to grasp a cup of coffee. It's simple and straightforward for us humans, but for robots, it's a bit more complex. So this knowledge has to be imparted into the robot so that they could successfully grasp the object and navigate in the environment. So this is where our project comes into picture, basically. So we are trying to iteratively refine the grasp of the robot so that they could successfully grasp the object. For that, we have derived grasp quality metric. It's based on force closure principle. So force closure is basically if the force peak that is being applied on the object is acting opposite to each other that avoids a slippage, then that could be defined as a force closure on that object. So based on that, we have derived a metric which is this. So in this object, if we have two contact points for grasping that particular fruit, for example, if you could connect the two contact points and calculate the angle between the force, the surface normal on that contact point and the connecting line and sum them up, we could quantify how good the grasp is. So basically, a good grasp would be forces applying exactly opposite to each other, and they almost coalesce into a single line. So that's a good grasp. So using this grasp quality metric that we have derived, we have developed two models. One is a baseline model, which is totally analytical, and it's just improving the grasp quality by adjusting the contact points iteratively. So I'm not going to go into the baseline model. And what is more interesting is the neural network model. In real time, robot would not have access to the 3D model that it is trying to grasp. So in real time, what a robot could have access is possibly a depth image, and we can develop a partial point cloud with the depth image. So a point cloud is basically a 3D representation of the objects that can be used for processing. So what we could potentially have in real time is a partial point cloud. So the novelty in our project is basically the utilization of convolutional occupancy networks. So convolutional occupancy networks are a powerful 3D reconstruction model. So we could use the convolutional occupancy, the convolutions basically, to extract the latent features of the object that we are trying to grasp in the robot and use it in our neural network to help predict the grasp quality for that particular object. So if we could predict the grasp quality, we could use the gradient of the network to iteratively adjust the contact points to the direction that would achieve a really good grasp. So that's basically the idea in the neural network model that we have developed. Why this model? So there are a lot of other models which could predict how to grasp an object for the two-fingered gripper that we are concentrating. There are a lot of models that are available. But what is special in our project is that we are not actually just predicting how to grasp. We are iteratively adjusting it so that our grasp could be improved. So possibly a good grasp could even we could improve a possibly good grasp to achieve a higher success rate. So the thing, coming back to the coffee cup example is sometimes we may try to grasp a cup of coffee and we could successfully grasp it. So that's what the current models are doing. So it just looks into the object and try to predict how to grasp it. But in our model, imagine our vision is compromised for some reason, or we may not be paying enough attention to successfully grasp it. We use a sense of touch to adjust our contact points so that we could successfully grasp. So most robots that we have now do not have this sense of touch. So our project is exactly bridging the gap that is there. So we are trying to improve the dexterity of the robot by iteratively adjusting the grasp so that the grasp is a little bit better, the quality of grasp is a little bit better, and improve the success rate basically. So utilizing this, we do have a lot of applications. Like the obvious applications would be pick and place or warehouse or logistic kind of environment where we have a 3D model that is available for us to predict how to grasp it. But this model could also be utilized in other advanced robots which are autonomous and are manipulating the objects in its environment, possibly in search and rescue or assistive robots. So this model could help improve the grasp quality in all those scenarios, and it is a tiny bit of step towards achieving a human level dexterity for the robots basically. So that's our project basically, and this is a kind of a demo that shows how we iteratively improve the grasp quality. So okay, so this is the first potential grasp that was selected, and we can see the improvement happening in the next iterations. So there was a little bit more, the grasp has adjusted a little bit, and then in the consecutive iterations, the grasp keeps improving until it reaches potentially a grasp that looks like this, which is again a straight line, like how I explained in my metric, where if the forces that are applied on the object is exactly acting opposite to each other, then that would end up in a force closure and the object could be grasped successfully in that scenario. So that's the demo for the project, and thank you everybody for listening to me, and have a great rest of the evening.
Hold on to that. Do you have a question? Yes.
Thank you. In the demo, you've got the model of a banana. Can you just explain how many other variations of objects that you've used and processed? Thank you.
We have used YCB dataset, which is the state-of-the-art benchmarking dataset that we use for robotic grasping tasks, like task manipulation tasks basically. That dataset consists of around 71 household objects for grasping. So that's what we have trained the model on right now.
Thank you.
Right, you tell me if this is okay?
Yeah, that's good.
And yeah, and then when you're ready.
Yes, so I'm Tranter. This is my project on tracking multiple human pose estimations. So it's not tracking as in I know where you live sort of tracking. It's more of within a 2D environment tracking the individuals within the screen. It was a lot of fun when it wasn't the most stressful thing I've ever done in my life, but it got very good results in the end. So the idea was the university already has a 3D pose building system. It takes in 4 camera views and then will build a 3D person. It's fast, but the goal was to try and make it faster. So my 2D tracking comes in, it tracks them in the individual cameras beforehand to see if it can avoid the need to call the graphical neural network that builds the poses. So obviously originally we had to start with the 2D tracking. There was a multitude of different techniques I could have used. There was a Euclidean distance, so finding the closest person, finding like a spatial overlap, or an object key point similarity, which is how similar the key points are, or a percentage of detected joints, which is very similar. It just tells you how many joints were detected on that person. In the end, I ended up using I created my own kind of an adapted intersection over union that used a few key points from just an intersection and also the Euclidean distance. So this video here is my tracking working on the MUPOX dataset. So the main thing I was trying to do was track someone even when they became obscured. So for example, the green person just disappeared. In a second, the blue person will fully disappear when those two overlap. And it was able to keep track of them. That was the main goal. It became even more impactful when I implemented it on the uni system. So we had to put it on all 4 cameras. When the IDs match over every iteration, it will not call the neural network. We found that calling the neural network took about 0.01 seconds, and skipping it because of this tracking took about 0.0001 seconds, 4 zeros. So the FPS on the overall system, we went from, so with 3 people being estimated, it was originally estimating at 14.4 frames per second. And then after my system was added in, it got to 19.2 FPS. And no, that's with 3 people. Then with 2 people inside of the estimation, it went from 19.4 FPS to 27.1 FPS. So both was above 30% increase. I would have been happy with 5. And we got a 33 on the first one, 39, so about 36-ish % increase overall. It's being used on the system right now. So if we did go down to the lab in MB306, it's implemented in the system. The hope is that it will continue to be used. I know there's a PhD student at the minute that this work will benefit him because it just speeds up the overall process. If another student came along, they could have more projects to help with them. But overall, it just works pretty well, already made an impact. So yeah, thank you for listening.
Still up for the question?
Yes. Oh, yeah.
Here's a question, Joe.
Hi, Taylor. Really nice work. And we can see there's 3 people in your video, right?
Yes.
I wonder how many people at mix could be in the scenes and the system still work fine.
Yes. Yeah. So because I did all the tracking based on the key points, you don't even need the image of a person. You just need the location of the key points. I was only able to test it on the max of 3 people because the 2 data sets I used only had 3 people. But theoretically, it could be any number of people. Obviously, the more people being used in the 3D estimation, the slower it gets. So we had 19 FPS with 3 people, 27 FPS with 2 people. So the more people you add to that, it gets slower. But within the 2D tracking, there's not any limit. Obviously, you won't want to go too high, but I reckon probably around within that sort of size frame, 10 people maybe, because the more people you get, the more people overlap and the more predictions get a bit off. But I reckon 10 numbers would be a good number for that one.
All right, well, let's thank all the presenters again. And then I'll hand over to Vince. All right, sorry to interrupt your networking, but we want to just proceed to the award ceremony. So what we will be doing is the panel members will announce the winners and hand over the trophy. We'll take a few pictures and we'll go to the next one. And so the first one is Joe.
Yes.
Do you want to say a few words about yourself as well?
Okay, thank you very much. It's my pleasure to present this award to the student. My name is Zhou Yun. I'm a teaching fellow in Aston in AI, and I'm also the program director of MSc AI and AI with Business Strategy. It's my honor to announce that this award, Innovative, is go to Taylor.
Can you all take a step forward so we don't have to join hands? That'd be great. Excellent.
Well done. So the next award on most impactful project, Gemma.
Thank you. Yes, I'm Gemma from DRPG, and it's been a great pleasure to judge all of the students' work. Oh, sorry, to judge all of the students' work, and really good to see that the feedback was implemented this evening as well. So I'm proud to announce that the winner of the most impactful award is Nissy.
And so the last award, the community award. So all of you have chosen.
Yeah, I think it was a tough decision for us, and I think you guys helped us a little bit to make a third finalist, third winner. I'm from Eshta. It's an AI startup, so we provide AI training and consulting for businesses as well as for academics. So here, what we are doing is Community Choice Award. So do you know who you voted for? No, no idea. Okay. Actually, I don't know how to pronounce the name. Izegbua? Okay. So how do you pronounce it?
Izegbua.
Izegbua. Okay. Abdul was also leading second, so you missed it by a small margin, but very good work too. Yeah. So I think we need to clap for Abdul as well.
Thank you. Well done.
Thank you all very much.
Excellent. So that concludes the award ceremony. And do you want to make some announcements before we break?
Thank you, Ulysses. Yeah, so thanks to all of you for being here and the excellent speakers, excellent talks. Well done for the award winners with your fantastic new printed awards. Thanks to DRPG for providing those. They're really cool. And for sponsoring and for giving a really cool talk, showing us your cool stuff. Thanks to Atanas. Thanks to Ulysses. And thanks to the judges. And
Thanks to Aniko.
Aniko, yes. In the ether. And to Nathan. Thank you, Joma. Thank you. And Andy, thank you, Joe. Was there anything else? Thanks to Aston University, of course.